Hello and welcome to our brief introduction to diffusion, osmosis, and osmotic pressure. The first thing we're talking about today is diffusion, which is the process by which gases, liquids, or dissolved solids move to evenly fill their containers. This is marked by the net movement of the particles, whether it be the gas, liquid, or dissolved solid, and it moves from an area of high to low concentration in the container until an equilibrium state is reached. The random movement is marked by the kinetic energy of these molecules. So in this example here, we have the cluster in box A of red particles. Say that's some salt you dropped in a glass of water. Now, where you drop the salt in is going to be the high concentration. It's going to move towards the area of low concentration on this right-hand side. Now, over time, the salt particles will continue to dissolve and evenly fill the container of water. So in this video here, you can think about adding the dye into the water in the petri dish. Now, over time, as you can see, the dye will go and evenly fill until it becomes an aqueous solution or equilibrium is reached. It's going to be evenly distributed, the food coloring into the water. And now here you can notice the one on the left hand side dissolved or dissociated or filled the container much more quickly, and that's because the hot water, the particles have a higher level of kinetic energy. More kinetic energy means quicker rate of diffusion, whereas in the cold water on the right, slower rate of diffusion.
The next topic we're touching on is osmosis. It's the diffusion of water across a selectively permeable membrane. Selectively means that it's filtering out the water, and whatever solute is in there will stay there and not move with it. So it passes from a lower solute concentration to a higher. So if you have a lot less water with a lot more salt, it'll move over to even out on the other side. You want to balance between the cell and the environment. It's crucial for maintaining shape, for maintaining function of the cell. Here's an example of osmosis. As you see, the water molecules bind to the sugar, and so then the free water molecules are able to move from the lower concentration over to the higher concentration. So the water balance inside and outside is even. You'll see over to the right that there is more water here, however, there's the same concentration of sugar, so that water is able to balance out. That's osmosis.
Now moving towards osmotic pressure, which is tied to osmosis, in that is the pressure required to stop the movement of water to high solute concentrations during osmosis. So, and there's an equation here that we'll use. Basically, pi is the symbol for osmotic pressure. The units are atms, equals molarity times a gas constant. The units are in there, times the temperature. When you're using this equation, you have to make sure that your units are the same, so they cancel out and you get atms at the end. There's three terms that I'd like to discuss: isotonic, hypertonic, and hypotonic. Now let's think of a cell environment. So basically what this means, in an isotonic environment, there's equal movement of solute between a cell bilayer. So there's equal movement of solute in and equal movement of solute out. Hypertonic means, and excuse me, I didn't mean solute, I meant water. A hypertonic solution means that there is more water coming into the cell than out. So this is going to lead to a cell bursting. A hypotonic description means that there is more water leaving the cell than there is going in. So this is going to shrink the cell. Now, examples of osmotic pressure are honey and water distribution through trees. We can think of honey in that there's very high sugar concentrations in honey. So if you think of a bacteria, this is why honey remains stable for a long time without any refrigeration. So if you think of a bacterial cell entering a solution of honey, the water in the bacterial cell will diffuse across the cell membrane into the honey where there is higher solute concentrations, and the cell will thus die. And now in trees, water, or as scientifically called mycelia, will uptake water from the ground, and now this water must move upwards against gravity. Well, how does that happen? Well, there are higher solute concentrations in the plant cells or in the leaf cells, and so that osmotic pressure is high enough so that the water moves upwards and into those leaf cells.